Hello, thank you for joining us for this Microsoft Reactor live stream event. Today we are excited to have Stefano Demiliani, a Microsoft MVP for business applications. He will be presenting tips for using Azure Functions in production. This session will run for approximately an hour with time for questions at the end. If this is your first time joining us, please note that for our team's live session, there is a 20-second delay from speaker to audience. So feel free to post any questions that you have in the moment in the chat, but note that our speaker may not respond straight away. And most questions will be saved till the end of the presentation. Additionally, please be aware that we will be recording this session and then posting it to our YouTube channel. I'll be sharing that link to our YouTube in the chat shortly. You might see on this session slide the survey link. We ask that all participants, if possible, submit the survey. The event code is 11592. I'll drop that link also in our chat. We use that survey to get feedback, build on our programming, source more content that better aligns with what our community is looking for. And just as a reminder, all of this content is free. So definitely, take advantage, fill out the survey, let us know what you're hoping for and hoping to gain out of this experience. At this time, I'm going to pass the mic over to Stefano and let him begin. Thank you again.
Thank you, Rebecca. Thank you all to be today. Today we will talk about how to use Azure Functions in productions, and so best practices for going to production with Azure Functions. 2 words about me. I'm Stefano Demiliani from Italy. I'm a Microsoft MVP and MCT. I work as a CTO and data solution architect for a company in Italy, and here are my references if you want to reach me on my socials and on my channels for questions and something, all what you need. We are talking today about Azure Functions. I hope that all attendees listen a bit about Azure Functions. Azure Functions, as formal definitions, are a serverless compute service that permits you to run event-triggered code in the cloud without having to explicitly provision or manage infrastructures. So Azure Functions are a fundamental building block or serverless application, and so for creating cloud apps. Azure Functions starts from events, so react to events that can be of different sources. Event means something that happens in the cloud and then can trigger functions. Events can be HTTP-triggered functions or can be events attached to Azure resources. Azure function is when events is triggered, the Azure function is as a code, and this code is triggered by the event and can be authored on a set of different languages. And you can also have integrated monitoring for this code. And then Azure function has outputs. So outputs means that the Azure function sends a result to can send a result to a large set of resources, and the results can be also streamed to you as HTTP response. Features about Azure Functions. Azure Functions permits you to select the language you want for creating Azure Functions. So you can choose, you can write function using a different and a large set of language that can span from C#, F#, Node.js, and many other type of functions. Azure Function has what is called a pay-per-use pricing model. Pay-per-use means that you pay only for the time you spent on running your code. So it's quite useful this time of using Azure Function because it permits you to save a lot of money. Azure Functions permits you to bring your own dependencies in the project. So Azure Functions supports NuGet and other and NPM for package managers. So you can use all your favorite libraries inside your Azure Functions. You can use third-party libraries inside Azure Functions. You can use also your custom DLLs creating for the on-premise world inside the Azure Functions for running code in the cloud. Azure Functions has integrated security, so you don't have to think about security. Security is managed by the platform, and you can protect Azure Function with keys, authorization keys. You can also protect Azure Function with other authentication providers like OAuth for Azure Active Directory. You can protect Azure Function with third-party authentication provider like Google, like Facebook, Twitter, or other Microsoft accounts. So you can have totally built-in integrated security for functions. You have a simplified integration mechanism. So your Azure services and your Azure function can easily be integrated with third-party services like, for example, Twilio and Grid or something like that for communications. There are a lot of built-in services connected to Azure Functions. And you have a flexible way of development because you can code your Azure Functions directly in the Azure portal if you want. But you can also create Azure Functions with external tools like Visual Studio or Visual Studio Code. And you can integrate and set up continuous integrations for code deployments with tools like GitHub, and for more advanced development scenario, like, for example, Azure DevOps. Azure Function is an open source. So the function runtime is open source, available on GitHub. You can contribute on that if you want or respect that. Azure Function has also the possibility to be deployed on-premise. So you can debug and test completely Azure Function on-premise, but you can also deploy it on-premise if you want. We'll talk a bit before about the tiers. Azure Functions quickly has 2 tiers available that permits you to run Azure Functions in the cloud. The first is what is called the dedicated tier. The dedicated tier means that you don't pay for function execution, but you pay for a reserved set of resources in the cloud. It's like a pay for AVM. And you are inside that that pay resources, you can execute all your functions that you want. So you acquire a set of resources, and you are responsible for scale in this case. So if these resources acquired are not enough or are too much, you are responsible for scaling up or down your Azure Functions. And the other possible way is what is called the dynamic tier. The dynamic tier means that you pay for the number of executions of your function. So it's a pay-per-use, pay-per-usage model. The platform is responsible for scaling. So you don't have to think about scaling or something like that. And remember that what is called the dynamic tier, you pay. I say that you pay per execution, but the pay per execution is not only the number of executions, but you pay for the number of execution and also the duration of your execution and the reserved memory that this execution needs. So this must be taken into considerations when you plan to use Azure Function or when you start using Azure Function, and we'll see tips for, especially in the next slides, we see tips for managing that. So for improving your Azure Function performances and then decreasing your cost, because the cost is affected not only by the number, but also by the duration and the memory that your function consumes. So in this session, we'll see best practices. So the idea is to give you a set of best practices that you should adopt when deploying Azure Function in the cloud. I've separated these best practices into 4 major categories, and we'll explore that in details in the next slides. So the tip number 1 is handle multiple function apps with few functions. If you have previously created an Azure Function, you know that when you create a project, an Azure Function project, it creates what is called a function app. And inside the function app, you can create different functions. Different functions that can do different things, interact with Azure services, external services, and so on. And when you create a function app, remember that the function can be a part of a big serverless architecture where components inside the serverless architecture can fail. And so if a function app fails, all your function fails. And to minimize the impact of your functions in a complex serverless architecture, is absolutely recommended to split functions into multiple function apps. Don't create one function app with all your functions, but create multiple function apps and try to make them independently deployable. And in this way, the consecution is that it's also independently payable. So separate function app for concepts and don't create all the function app inside the all functions inside the single function app. And another tip related to this is avoid long-running functions, because large long-running functions can have timeout. Timeout is different related to the plan where you are creating Azure Functions. So consumption plan has a timeout, and a default timeout of 5 minutes and a maximum of 10 minutes. If you want to have a more advanced timeout, more unlimited timeouts, you need to go at least in the premium tier if you are using the consumption plan, or you need to handle the app service tier. And remember that timeout is not always only affected by the duration of the call, but it's affected also by if your function imports dependencies, if your function imports third-party libraries, and this affects timeouts. So you need to handle and remember that. And whenever possible, it's absolutely recommended to refactor a large function into a set of small functions that can work together and react and respond in a more fast way, because a chain of function with small amount can help you to reduce the entire timeout of your infrastructure. And normally, one of the best practices is that each function should have a single responsibility over a single part of your software. So don't create a much smaller function that does all. Another tip is to handle cross-function communication efficiently. So if you have two functions that communicate, and this communication is a quite big process, so it occurs times, it's not recommended to do a direct function-to-function communication, but on many cases, on many scenarios, it's much better to handle this, for example, by using queues. So where a long-running process sends a message to the queue, and then another function takes the message through the queue and processes it, because it permits you to have a more reliable workflows, and permit also to react to failures of your workflows, because a message in the queue is persistent here, and you can then extract them from the queue also if the process fails. So for cross-function communication, the recommended way is to use at least storage queue. Storage queue are cheaper, so it's the first way that you can do. Storage queue has only a limit that individual messages are limited to 64 kilobytes. If you want to a more advanced cross-function communication, one of the best way to use is using the Azure Service Bus service, because the Service Bus service permits you to have more large messages sent to the queue of the Azure Service Bus, and so sent to the other functions, but also permits to send messages to multiple subscribers. So in the Azure Service Bus, you can create what is called topics. Topics, it means that you mark each message in the Azure Service Bus with what is called a topic, and as different subscriber can subscribe to an Azure Service Bus queue for topics. So if I'm sending in an Azure Service Bus message related, for example, to invoice, orders, and other type of elements, and I'm a subscriber that I want to receive only messages related to invoice, I can subscribe to a topic called invoice, and then I receive only that message. So it's very efficient for handling cross-function communication. If instead you have large volumes of signals sent to your Azure Functions, Event Hub is one of the Azure services born for this type of service. There are also another aspects that we don't talk about it today. There are for handling cross-function communication, so long-running workflows, and these are durable function or Azure Logic Apps that are a service that permits you to manage state transition and create long-running workflows in the cloud with a low-code approach like Azure Logic Apps, or with a full-code approach like durable functions. Another tip is that when you write Azure function, try to be stateless because Azure Functions should be stateless. So please don't create or associate state information to your data in a function, and do not store state information within the application. But state information should be handled attached to your data. So, for example, if you are processing orders, the order state should be associated to the order record and not associated to the function itself. So this is important to have functions should be stateless, so don't persist information inside the function code, but persist this information about states inside the entity, so inside the database or something like that, what you are using for handling communication between the functions. And remember that in a serverless architecture, your functions should do one thing. So be stateless and finish as quickly as possible. Another tip is related to handle exceptions. So in a production environment, you should deploy Azure functions that are defensive. So you should handle exception and design your function with the ability to restore from failures. For example, if you are sending messages to receiving messages from a database and then you are sending a message to another functions, a best way to handle this, if you instead of directly reading a large amount of data from the database and directly call another function to process this record per record, the best way to handle this in a cloud environment is create a message queue and then send this message to a message queue. The message queue, if an exception occurs on processing a particular record, the message queue, the queue permits you to track this record as failed, continue processing the other records, and then process the failure record in the next iteration. So it's much better for handling exception and so on instead of throwing a single exceptions. Another thing to remember is that you should validate the function input, because often I see functions that receives parameters, for example, in the query string, and these parameters are not tested and not evaluated with if they are safe or not. And this you can have problems if you don't do that. SQL injection or something, or other problems like that. So you should evaluate and validate input parameters of your functions. And also remember that we are talking about, a bit about, for example, queue. Queues have an interesting features, sometimes hidden features, I think, that if you have a function triggered by a queue that may be process a message that you sent into the queue, the Azure functions normally automatically handles retries. So if a function, if you send a message to a queue and you have a queue trigger functions, this function fails, this function try to reprocess the message sent to the queue for 5 times. And if the process of this message fails again and again and again, this bad message is moved on a parallel queue called a Poisson queue. And in this Poisson queue, you have all the messages that the function was not be able to process. And you should handle this, because in this way, you are not losing messages. And all the messages, some messages are processed, messages that cannot be processed are in the Poisson queue, and you should act accordingly. So the entire transaction is safe. Another tip where I want to spend also a bit to show it is what is called dependency injection. The scenario to describe dependency injection, one of the way where dependency injection I think is extremely useful is if you think a scenario where you have a function app with different functions inside this function app, and these function apps needs to use the same services. Imagine that you need to reference an external services, maybe quite large and complex to reference. The best way is don't create separate instance of this service for each function app you have, but if you want to improve performances and decrease costs, it's much better to reuse a same instance created at function startup. So scenario is, instead, if you have function 1 and function n, function 1, function 2, and so on, and function n, this function needs to create, when function 1 is called, need to create a reference of service 1, service 2, and service 3 that maybe are third-party service or DLLs that should be triggered and referenced in order to create the needed connection. Function 2 does the same, function 3 does the same. So you have a large work to do for each function that you call for instantiating the same services. It's much better to instantiate the services once, and then for each functions, create the previously instantiated service. This is a scenario available in Azure Function if you are using what is called dependency injection. And dependency injection can be, there's a library in the Visual Studio or Visual Studio Code packages that is called microsoft.azure.function.extensions that permits you to having enhanced features for Azure Function, and one of this feature is dependency injection. So to quickly show you how to do that, here I created a function. Imagine that this function is an HTTP triggered function, so it's called by another Azure or external system by sending an HTTP request. This function simulates another service, so it receives a customer as input, and then creates as an interface here a class, a module that creates two references, one for sending emails and one for sending SMS. Imagine that inside this, instead of only actually I have only a simple debug.writeLine, so a simple message that says that this service is instantiated. But imagine that here I have to reference external DLLs, I have to create external classing, create external connection to external modules, and so on. So imagine that I have to do a much more complex work that takes time. Instead of doing that for each single function, so here I have a function called function 1 that when triggered must create a reference of the SMS service and to the email service. Instead of doing this inside this function, what you can do with dependency injection is that you can declare a startup file as declared here. So a class called starttypes that inherits from function startup. In this class, you can create a service, an instance of your services that you need, or your external connection that you need. So here I'm registering my service. So one is the email alert, and one is the SMS alert. So here I'm creating an external connection to the email service, and here I created an SMS connection to the SMS service. So once for functions, and then when the function is triggered,
Stefano?
Yeah.
Apologies to interrupt. We just had a request from some of the audience to increase if there's a way to increase your demo font size. Is there a way to zoom slightly on this screen? Just because thank you so much. Sorry to interrupt. Thank you.
No problem.
Oh yeah, much better. Thank you. Okay,
so what I show here, sorry for the resolution, is that as I said before, I have a class. In this module I call here alert module. I have two interfaces where I created a connection to the external service. So the iAlert service create a this is the alert module. So I have a connection with a function called send alert and a function called send alert in the email service. Imagine that inside here I'm referencing a connection to an email service, external email service, and then imagine here that I'm creating a connection to an external email SMS service. But this can be also a connection to an external database or an external application. So the concept is different service that needs to take time to be connected and resourcing DLLs or something like that to be instantiated for creating the connection. So instead of doing that inside the function code, so this is my Azure function. This is my Azure function. So instead of doing that inside the function code, with Dependency Injector, you can create a startup file. This startup file is a class called startup that inherits from function startup. In this method, you can override the configure method, and in this method here, you can register all your services. So I'm creating here an instantiation of this class and an instantiation of this class because I want to instantiate the email service and the SMS service. So once for the entire functions apps, and then in my function, I'm calling this. So if if I place a breakpoint here, and if I test this function locally, what I want to show is that now the function runtimes is going on up, and if I execute the HTTP trigger function, so as you can see now the function is actually not triggered because I have no breakpoint here. But if I go on my browser and I trigger it, the function is triggered. Now the breakpoint starts, so my function is triggered. And as you can see here, if I go, I debug this variable, I have two connection with external services created. So these creations is not triggered inside this function, but it's created on the startup. So the first time that Azure gives up my function app. So and here I can go and process the function. So here I'm sending the first service is the first service is the email alert, and then I can send the email, and the second service is the SMS, and then as you can see it's created the send alert and go into the email service. The second trigger is the SMS service, as you can see here, and then it calls the send alert method of the SMS service. So the concept to understand here is that my function, instead of creating connection to external services inside that function, it creates this connection once directly from the function startup. So at the function startup level, so here, and all my functions, if I have here more than one, function 1, function 2, and function 3 that uses these services, they can use the service directly, so without recreating the connection to this service. Extremely powerful and useful if you have, for example, connection to external applications, or if you have connections to services like database, Azure SQL, or something like that, because it reduces the time that your functions loads, and it reduces the resource needed. The tip number 7 is to you should choose the right plan for your scalability needs. So as you can say before, we have a consumption plan, a premium plan, and a dedicated service plan available. You should evaluate what function is the best for you. So the consumption is the default hosting plan. Consumption means that you pay for use. It scales automatically, even during when you have high load of period. And function apps in the same region can be assigned to the same consumption plan. So you have no downside or impact of such an app. And you can do that. You can also move for move, and the billing is move function between plans, and the billing is per execution and memory. Remember that the consumption plan has only a drawback, and you should check if it affects the project for you. And this drawback is what is called the cold start, because in a consumption plan, function apps are not immediately available to a client. But the first call that the client does, the function app must be triggered up from the Azure App Service, and you should have a cold start. So cold start means that you should have a small delay for the first time that you call the function. The premium plan instead supports the follow a set of other features. The first feature is that it doesn't have the cold start, because in the premium plan, all your Azure Function app are perpetually warm, and so are perpetually up, and they can react immediately to events, while in the consumption, it takes a bit of time for the first time. In the premium plan, another important feature, in my opinion, is the virtual network connectivity. So they can be connected to your virtual network and so local resources. You can have a unlimited execution duration, a more predictable pricing, because you have premium instances, and so you can price is more predictable. And the billing is based on the number of cores, secondary memory used on this. So remember that the premium plan, also if you are not using Azure Function at all, you have a minimum or monthly cost, but because in the premium plan, there's a service that perpetually checks all your functions deployed and takes them perpetually active and warmed. So a small amount of cost in the premium plan is always present. Premium plan is useful if you want to, you have apps that must be executed continuously, and there must be, if you must react immediately to events. If you have you need function with a long timeout, premium plan is recommended. And if you have virtual network, if you need virtual network connectivity, premium plan is recommended. The other available plan is what is called the app service plan. The app service plan is useful if you need custom environments. So if you need custom environments, custom software to execute your functions and so on, not available in the app service tier, you need to create an app service plan. So where you can install those custom DLL, something like that. Or if you have a large set of functions that you can execute a lot of time, and you can have a predictable environment where you want to do that. In certain situations, it's cheaper for you to buy an app service environment, so a set of resources, instead of paying per use. Remember that the drawback, in my opinion, is the scaling, because scaling is must be manually done by you. And this should be available. You can enable autoscale. Autoscale means that you can goes for a set of create a set of resources, minimum and maximum, where your environment can scale. But this is only the only available option that you can do for enabling that. And if you have function apps, for example, in consumption plan, you can start from a consumption plan. It's quite common scenarios. And maybe during your business days or your business time hour, you need a more powerful feature, more advanced features not available in the consumption plan. Remember that you can also move as an Azure function from a consumption to a premium tier as you want. So to do that, you can create, and you can move, I mean, in this case, I mean, temporarily move. So you can move a function from consumption to premium for a set of hours where you need the more power, the more features, and then go back to the consumption. And this permits you to absolutely increase performances and save money. To do that, you need to create a premium plan with the same resource group where you have the consumption plan, so where you have your functions. Move this function up to this premium plan, scale back down to the consumption plan when all is finished. And then you need to delete this premium plan, because as said before, a premium plan means that you have a small fixed price cost every time, because it's the service that takes your function warm. So you to do that, you can use, for example, an Azure Clip script that can be also scheduled, where you can, for example, execute, create a premium plan with the minimum instance, maximum instance, and the type of plan you want. You can update the plan, update your function app to move from the consumption to the premium plan. Then So this two operation does exactly the same. Does moves update the Azure plan from your app to this plan, and then deletes remove the third line moves your SD app, so your function app, to the consumption plan, and then the fourth line deletes the premium plan. So 4 simple steps that you can script, and that permits you to, for example, moving the function from consumption to premium in my business hours, or for example, in the day where I need more power. Tip number 8 is related to a scale controller. So the Azure function uses a component. This component is called scale controller, that permits you to monitor whether a function must be scaled out or in. So the scenario is that when you react to events, a scale controller creates an instance of your functions, and the scale controller is responsible for increasing or decreasing the instance of your functions. And to improve performances and decrease cost, one of the tips is reuse connections to external resources when possible, as said before. Please don't share storage accounts between function apps. So if you have created 2 function apps that does different things, don't create this function app in the same storage account, because this affects the scaling. So if function app share the storage accounts, cannot be scaled independently. Async programming is necessary to handle scaling accordingly. So write function with async, and receive message in batch if possible. So it's much better for improving performances. And you can also increase or decrease the maximum number of processes that your function runtime can create by going to the app settings and set a property called function worker process count. Important the storage account, because it's one of the errors that normally I see on many Azure function deployments, and this affects scaling. So don't share storage accounts. Tip number 9 is related to least privilege. So least privilege principle should be always respected. This means that if you have a set of functions that are deployed inside the permission set called X, so shares the same permission sets, this function does different things. It's much better to use a scenario like this, so where you create a permission set for each of these functions, and these permission sets are different. So don't share the same permission to all your functions, but instead gives the appropriate permission to your set of functions, because it increases security of your entire solutions. And use also the shared access signature features for accessing resources. So if you only need to read the blob storage, create a shared access signature with read permissions only, and use this inside your function. Don't use always the most full permissions. Azure Key Vault is another tip that I always remember. So if you have Azure function that needs to use secrets, don't store secrets inside the Azure function, or don't store directly secrets inside the Azure function configuration files. But it's much better to create an instance of a service called Azure Key Vault. Inside, this is a service born for security. Inside this service, create your security variables, for example, password and username, like in this sample I created. Create an access policies inside the keys of evil definitions for your function app, so permissions for your function apps. Then in your function app settings, create 2 settings that retrieves the values from the key vault by passing the identifier of the key vault. So 2 settings, and from these settings you call a Microsoft.key vault and take these settings from the key vault. So you are not storing inside the function application setting directly the password and username, but you retrieve that from the key vault. And then in your code, you can simply use environment.get environment variable and name of your variable, declare the variable on the key vault, and so on. So this is useful for doing secret and retrieving secrets, and absolutely recommended and to do if you want to improve security of your function. Another tip is related to authorization and authentication. You should use authorization keys when you are in development and testing. So authorization keys means that keys that you can specify for functions and that you can use share with your external clients to call your functions. And you should use authentication and access restrictions when you are going to productions. Authentication means, authorization keys means that you can create, when you define Azure function, some keys. These keys can be function keys, so required for each function, or can be host keys. Host keys means it's a particular key that can be used for at the function app level. So if you have a function app with, for example, 2 functions, a function key is a key different for each of function, while a host key is a key unique to the function app level. So if I want to create function 1 and function 2, if I'm using function authentication, I need 2 keys, one for function A and one for function B. If I use the host key, I need only 1 key, and I can call the 2 functions. For productions, you can use authorization keys, absolutely. But in many scenarios, especially if you are integrating with Azure resources or something like that, it's much better to use app service authentication. So you enable Azure Key Directory. You can use Azure API management. We'll talk about that in a few minutes, and so on. So you can also use client certificates or something like that. But for example, Azure Key Directory permits you to centrally manage connection, for example, password to the Azure SQL database or other type of connection, and you can simply manage this from Azure Key Directory or the Azure portal, and your function can directly use these credentials without going to share keys or something like that. I talk a bit about Azure API Management. Azure API Management is an interesting service that normally I recommend when you go into production with a large set of functions, because it permits you to have something like a wrapper to your Azure functions. The scenario is that instead your clients, instead of directly call your Azure functions, they call the Azure API Management, and the Azure API Management has an endpoint that in turn call your Azure functions. And with Azure API Management, you can specify all the policy you want. And just a very quick demo of the Azure API Management, how you can do that. Here I have my Azure portal. In my Azure portal, I created an instance of the Azure API Management. Simply go to Azure API Management and click on Create New. You need to specify the Azure region, and then you have this service created for you. Here you can go to APIs, and in APIs you can import on your Azure API Management a set of services. What we are calling today is Function App. Function App, you can browse for one of the functions that you have inside your Azure subscription. So this is all the functions that I have published today. For example, if I select this function, it's showing the names of all the functions that you have inside this function app. In this case, 1. I can click on select, and then I have a single endpoint that I can use for calling this function. So the URL is this base endpoint / name of the function app, and if you click create, then you can specify policy. So you can increase the security and controls of your function app, because you can specify, for example, inbound policy, outbound policy. You can specify who can call the function. You can filter, for example, external IP. that can call from functions, things that you cannot do that on other ways, in different ways. You can, for example, specify how much incoming call can be executed, and so on. So, as you can see here, I have my methods embedded into Azure API management, and for each method, you can specify inbound processing, backend, outbound processing, so rules that applies to your function. So, for example, if I'm going to inbound, so policy that filters the inbound traffic, I can specify filtering for IP, rate limit, response query parameters, header keys that are mandatory or not, quota by key, and so on. So a large set of policy that you can specify for your function, for controlling your function. So for production environment, I think it's absolutely interesting and recommended way of working with Azure Functions. Another interesting feature is the traffic manager feature, because one of the common requisites that you deploy an Azure function in your preferred region. For example, imagine Western Europe. But then I have customers that goes from West US or East Asia, so different locations in the world, and they need to access my function, and they need to react quickly to this function. In these scenarios, is recommended to, if you want to increase performances, is absolutely recommended to deploy the function into different regions. So West US, West Europe, and East Asia, not only one single region. But if you deploy a function in different regions, it means that you need to give to your customer different endpoints. If you don't want that, but you want to have a single endpoint to access the function, you can use Traffic Manager. And Traffic Manager works at a DNS level. It acts as DNS-based load balancer, so permits you to have a single endpoint that, according to a routing method that can be geographic. Geographic means rules that you can specify at geographical level, or can be performance. Performance means that it redirects to the lowest latency endpoint. And in this way, you can have a single endpoint that your customer can know, and these are redirected to the correct Azure Function instance automatically for you. Another tip is related to slots. When you deploy an Azure Function in the cloud, it's automatically deploying in production. But sometimes this cannot be the way you want, because imagine that you have a function in production now, and now you are working with new features, and you want to share these new features in preview to a set of customers. If you deploy that in production, obviously these are available for all. In Azure Function has an interesting feature called slots, where you can simply create a new slot, deploy with a name, as in this case, I created a slot called testing. You can deploy the new version of the function to the testing slot, and your set of customers can use the testing endpoint, while others are using the production endpoint. And you can also redirect to the testing automatically. And when you are ready to deploy the testing in production, you can simply swap the slots. So you have a function to swap the slots. Testing becomes productions, and also settings are moved. And this permits you to automatically move features to production without affecting users. Another tip that normally I recommend is always enable monitoring, because when you create an Azure function, the first thing that the Azure portal asks for you is, do you want to enable application insights? I recommend to do that, because monitoring can save your life in the cloud. It permits you to have real-time observability of your function. You can analyze and debug all what happens inside your Azure function. So you have Azure Monitor and something tools like that that permits you to inspect all the telemetry of your function in details. You can enable alerts. Alerts means that you can be notified if something if you have problems in the cloud. For example, if you have a larger response time, or if scalability is not enough, so you can react to this. Related to deployment, you can deploy Azure Function easily in the cloud with Visual Studio or something like that. But if you want to embrace the DevOps philosophy, it's recommended to use Azure DevOps for. You can use Azure DevOps for CI/CD pipelines in the cloud. Azure Function has native support for this, so you can, if you are using a repository inside, for example, Azure DevOps for storing your Azure Function code, you can simply create build a release pipeline. In this case, a release pipeline. You select Azure Function as a template for this release pipeline, and it creates for you a pipeline without doing nothing that permits you to build and deploy your Azure Function code directly in your subscription. So you can control the deployment of your Azure Function. As a last quick example that I want only to show, to emphasize some of this notification, I have a project here. We are with the real world scenarios that I quickly show. Imagine that here we have sales stores located in different parts of the world, that they upload some CSV files to a blob container in a container called active list. This process is an invoicing processes, handled totally serverless. So the scenario is that customers sends this CSV file to the blob container. When this file is loaded, a container, a blob trigger function is triggered. This function is called generate billing items. This function is responsible for generating billing items by going to a Cosmos DB database and retrieving the prices of the items ordered by the store. These billing items are saved in the Azure table. Then it sends a message for creating a new invoice to a queue in the cloud called invoice generation request. When a message arrives to this queue, a new Azure function is triggered. This called generate invoice function. This function creates the invoice, saves these objects to the same Cosmos DB database in an invoices collection, and sends a message to a queue called invoice print, and another message to the invoice notification request. I can go directly to this diagram. So scenario is that CSV is loaded to the Azure Blob Storage. A function retrieves prices from the Cosmos DB database and then sends the request to the Azure queue and the Azure table. A function for invoicing is triggered that creates the invoice and sends a message to two queues. One is the printing request queue and one is the notification request queue. The printing request queue triggers an invoice printing function that creates a PDF of the invoice and then save it to the blob storage, while the other function, the notification sending, is a function that is automatically triggered and then sends the invoice via SMS or email to the customers, a notification that an invoice is ready to be downloaded, all in a completely serverless way. Just to quickly show this project and show some tips about this project. The first, I have here two ways of creating the project. The first is what I call all-in-one project. So all-in-one project means that I have a single Azure Function app project with all the required functions. So as you can see here, generate billing, the function is the first function. And we'll go in details later. But what I don't want to, let me jump back to the resolution. First way to do, most simple way to do is a single function app with all the functions inside, so 1, 2, 3, 4 functions inside. As said before, it's not the recommended way to do that, because if you create a single function app, this single function app is deployed in a single plan, so you cannot scale these 4 functions on different plans. So if you need more power, for example, in the generate invoice function, you cannot move them. Or if, for example, if print invoice is a function that for you can be moved to a more cheaper plan, you cannot do that because we have a simple project with all the functions. So it's much better to create the function into different function apps. So in these other projects, I have a function app project for each function. And I go back to this diagram. This means that I have a project for each of these 4 function apps, and these projects can be moved on different plans, on different subscription, and so on. So much more scalable and much more performant. And if I go, sorry, wrong Visual Studio. If I go inside each function, so for example, I go in the generate bid united function, is the first function triggered. As you can see here, this is a blob trigger function. So when the customer moves the CSV file into the active list in my blob storage, this is a blob trigger function, so it's automatically triggered. This function has a function has input bindings, output bindings. Output bindings, because the functions are multiple, so you can see here that you can specify multiple output bindings for your function. And then here I'm retrieving the CSV file. I'm parsing it, as you can see here. Here the function goes to the Azure Cosmos DB database for retrieving the price list, and then creates a table storage with the data. This is the function that goes into the Azure Web Jobs and creates the Azure blob, the Azure table, populates the Azure table. And here is the function that goes to the Azure Cosmos DB database, and then it calls the connects to the Azure blob Cosmos DB database, and then it retrieves the prices from the ERP database and the prices collection. So function with multiple bindings. And the same is for the generate invoice. So the invoice is, as you can see in this diagram, the invoice is the function that is triggered from an Azure queue and an Azure table, and goes into the Cosmos DB database and reads the invoice and generates a message. This function does exactly this. So is triggered from a message sent into the invoice generation request queue. It's a queue trigger. As some output bindings that are the Cosmos DB database to save the invoice, and 2 other output bindings that are the invoice print request and the invoice notification request, because I want to create an invoice by reading data from this table storage, and I want to save the invoice to the Cosmos DB database, and then sending a message to the invoice print request for printing the invoice, and then for invoice notification request for sending a notification to the invoice generation. So multiple bindings for this invoice. This is a trick that you can use inside your function for improving your performances in the cloud. So this ends my overview, my tips. I recommend to keep these tips when you go in production with Azure Functions. I remember this link. In this link, you can follow a learn path where you can see the topics that I show today. So I recommend to give it a check. Please join the Reactor community. because you can have more information about events and next initiative from Microsoft. And I recommend to fill the survey because it's handle and useful for Microsoft and for the reactor organizer to turn up the next events and the arguments that where you have interested to approfondite. So if you have some questions, feel free to do that in the chat window, or otherwise I can answer them later on my socials or something like that. So I can see that there are some exceptions. There's some. Is there a way, any way to add new provider to eLogger? Yes, you can. You can use your providers. You can add your login provider, and you can use your custom provider for loggings instead of the standard iLogger. Are there any real-time examples where we can use consumption and premium plans? Yeah, real-time examples are what I think that what I've described in these scenarios. Normally, consumption plan are useful if you have simple functions that cannot be affected by the low start and have not particular needs like VNet connectivity or something like that. If you are in this case, my recommendation is normally for a consumption plan, and then evaluate by using telemetry. Evaluate if you need scaling during your everyday usage. Maybe within the premium tier only for when you need that. And I provided in this slide how to do that simply by scripting these 4 Azure Key PowerShell commands, and then you can use them for scaling your Azure function. The example was a good idea, but we don't really understand it yet. Yes, I agree that the dependency injection. The dependency injection example, I show it quite quickly because the objective today was to send you a set of tips for handling the Azure function, and the dependency injection was one of them. Dependency injection is useful if you want to connect to external services, because you create a connection once, and then the connection is available to all the entire set of functions. It permits you to save money. For understanding it, I can share with you a link, a GitHub repository with all the samples I showed today. So this will be shared with you, and you can inspect these samples that I provided. It's quite easy because simply you need to create a startup class that inherits from the function startup. Inside the startup class, you need to create the connections to your services, and then this is available for you because it's triggered at the function app startup, and then you can use this inside your function. Other question. The zooming, I agree that zooming. I think that all is okay. Is there a way to apply a different container implementation? AG autofact inject. What you mean by different container implementation? I not understood this last question, sorry. Last question is not clear to me. If you can, for example, you mean IOC containers? What I don't understand. So to handle dependencies, you can IOC container like out of fact or something like that can be can be applied to Azure Function. Normally, what I use for dependency injection is, and what I recommend is to use dependency injection because I think that dependency injection has a built-in a more easy way to support. But out-of-fact on Azure Function can be useful, can be used. Absolutely. I think that I have a sample for using Azure out-of-fact, for example, in Azure Functions. My recommendation is is to use dependency injection because you have built-in support for this in the Azure Function runtime, so it's much better. I think that all questions are solved. So if
there was a question on Python.
Sorry, I missed that. Python. The question is Python one of the language that can be used? Yes, Azure Function can be created while using Python. Yes, the answer is yes. I think that there's some reference, if I remember, in the Azure Learning Catalog for creating Azure Function with Python. Personally, I'm not a Python user, so I prefer other type of languages for creating Azure Function. But Azure Function, yes, can be. You can create Azure Function with the Python Azure Python SDK.
Okay, and then there was one question they were asking if you have a talk on DI.
Actually, there's no plan for that, but I think that we can. Maybe we can. I can collect this feedback, and I can talk with the reactor organizer to do a session, especially on DI. Yes, we can do that.
And the last request is, sorry. The last request was, if you don't mind going back a slide to the AKA link.
Yes, slides will be. I will share with you all the slides. Yes, and the K link that the K link. You mean this link?
Yes, thank you.
This link is the link where you have all the learning part that covers. Yes, that covers this. But also the slide. These slides I will share with you with the links with the sources of the samples that I showed today.
Awesome. Thank you so much. The previous question, they responded, especially around logging and adding Serverlog was the clarification. I don't know if that.
Yes, the question before was if they can use custom logging, other types of logging. Yes, the answer is yes. You can do that. I don't have a sample today now prepared for showing that, but you can do that, and maybe if we plan a next webcast about more specific topics like DI and logging, we can provide this example on this, especially on that. So feedback collected, and we talk about Reactor Organizer to do this quite soon.
Wonderful. And at this time, we're a little bit over. We're past kind of the completion of this event. So if you have additional questions, do feel free to reach out. You can reach us on our Meetup Reactor pages. Just send a message to one of the hosts, and we will relay these questions to Stefano. Thank you all for joining us. We really appreciate you taking the time out of your day to be a part of this experience. Certainly, once again, If you have the time and availability, please submit a survey. We really appreciate all of that feedback. Thank you so much, Stefano, for you as well taking the time and doing this presentation. It seems like you had a lot of engaged attendees, so this is wonderful, and we look forward to hosting you again.
Thank you to all the attendees, and see you again in the next events. Bye-bye.